mathematics. So today I have just uploaded this video into the live session, but I think there is some mistake, so that's why it is not uploaded properly. That's why I'm coming with this question again, second time. Okay, so here into this question is given that in the circuit shown, the cells E1 and E2 are having a potential of 4 volt and 8 volt, right, and having some internal resistance. So here is given that E1 is 4 volt and E2 is 8 volt, it is given to you, and the internal resistance of cell E1 is given to you at 0.5 ohm, and internal resistance of the E2, that is 8 volt of battery, is 1 ohm, right? So this is in the question, it's given, right? Now we need to find the current through each of the resistances, and we need to find also the potential difference across each of the cell, right, each of the given cell, right, to find the potential difference, right? Now what we will do, we can simply apply the KVL and KCL over here. Okay, so here you can see this is the condition of the battery, right? So here you can see the E2 is nothing but 8 volt, so this is 8 volt, and E1 is nothing but 4 volt. So current is flowing from plus to minus, right? So here you can see E2 is greater than E1, right? Therefore current will flow with respect to I flow with respect to E2, right? Now why E2? Because you can see E2 is greater than E1, so the current will be flowing like this, like this, like this, like this, like this, right? And here you can see the current will split from this point into two parts, right, here and here, and again this component will be adding up over here, and again this I is reaching over here into the circuit. So here you can see across this circuit I current is flowing, I, right? Similarly, if I is flowing through this circuit, then definitely at this junction apply Kirchhoff's current law, that is sum of the incoming current is equal to the sum of the outgoing current. So here we can see, hi Amar vlog. So here we can see I is break into two parts. Let's say I2 is coming over right and I3 is coming downward, right? So from here we can write I is equal to I2 plus I3. This is one of the relation which is derived, right? Now since I equal to I2 plus I3, because this current I is split into two components over here, because this is the junction and current is flowing towards right as I2 and downward as I3, right? Now just take the main circuit. Into the main circuit, when the current will flow from as per the E2, because E2 is greater than E1, then we can say that the one part of the question which is given, that the internal resistance of the two source of voltage here, the EMF source, is 0.5 ohm and 1 ohm respectively. So what is the meaning of internal resistance? Internal resistance, that means some resistance within this battery. So let us represent it over here, 0.5 ohm for this 4 volt of EMF source, and here let's say is it 1 ohm as given to you into the question. equation for the 8 volt of EMF source. Now from the main circuit, what we can draw, the apply the KVL over here. So starting from here, what is the first point? That is plus 4 volt, right? Then after that 0.5 ohm into I, right? Then 4.5 into I, right? Then here you can see I2 is coming, so I2 into 3 plus 3 into I2, right? 3 into I2 and again plus 1 into I, because here you can see I2 and I3 from here is combining at this point. You can see again apply the KCL and you can see I is going forward to the top, right? I. Now this I is going to multiply with this 1 ohm, which is an internal resistance of 8 volt, that is 1 into I. So that we have written over here. Then this minus 8. So all this will add to give you 0, right? Now from here you can see 4.5 plus 0.5, that is 5 plus 1 6. So 6I plus 3I2 is equal to 8. 6I plus 3I2 is equal to minus 8 and plus 4. So that is equal to minus 4. That will be 8 minus 4, which is equal to 4, right? Because this 4 is also present over here. Now this will give you a relation 6I plus 3I2 is equal to 4. So let us say this is equation number 2, right? Now from this point we have 6I plus 3I2 equal to 4, and again I equal to I2 plus I3, right? If you consider this circuit, from here, what we can see, that 3 into I2 minus 6 into I3 is equal to 0. Why? Because I2 is coming from left to right. So if this is taken as positive, then the current is flowing from left to right, and the here into this circuit we have taken the flow of current like this. So I3 will be coming into the negative. So I3 into 6, this I3 into 6. So that's why it is minus, right? Now you can just write it as I2 is equal to 2I3. This is the relation, I2 equal to 2I3. Let's say this is equation number 3, right? Since I2 equal to 2I3, right, and I equal to I2 plus I3, so we can write I equal to, from this equation, I equal to I2, which is equal to 2I3 plus I3. So we can write I is equal to 3 times I3. This I is equal to 3 times I3, right? Right? I and 3I3. So this is equation number 4. Now what we can do, we can use this relation 6I plus 3I2 equal to 4, right? 6I plus 3I2 is equal to 4. So this will give you 6 into, in place of I, just write 3I3. 6 into 3I3, right? 6 into 3I3. We are using this equation. Equation number 2. So from equation number 2, we can write 6 into 3I3. In place of I, we put the value of I as 3I3 plus 3 into I2. I2 is nothing but 2I3. I2 is nothing but 2I3. right? This one is equal to 4, right? Then simply solve it. 6 into 3 18, 18 plus 6 24. So this will give you 24 I3 is equal to 4, which will give you the value of I3 as 4 by 24, which is coming as 1 by 6 ampere. So I3, the value of I3 is calculated as 1 by 6 ampere. So we can say that through this 6 ohm of resistance, what is the current flowing? This is I3 and the value of I3 is 1 by 6 ampere. So one part of this question is just started solving. I3 is 1 by 6 ampere. Now coming to the, just let me squeeze a little. Yes. Now this 1 by 6 ampere is calculated, which is flowing through this 6 ohm of resistance. So that is calculated. Here we have to find the current in each of the resistors. Now we need to find the value of I2. So just simple put the value of I2 as 2 times I3, right? So I3 is current through 6 ohm of resistance. Here this is I3, which is 1 by 6 ampere. Now the current through this 3 ohm resistance is calculated as what? I2. What is I2? I2 is nothing but 2 times I3. So use this equation number 3. I2 equal to 2 times I3. I3 is nothing but 1 by 6. So this will give you the value of I2 as 1 by 3 ampere. I2 as 1 by 3 ampere. So the current through this resistance 3 ohm is nothing but 1 by 3 ampere, right? So this is also solved. So current through I2 is nothing but 1 by 3 ampere. Here and just let me circle it. This is I2, right? So this part is solved. The current through this 3 ohm resistance is 1 by 3 ampere, and current through this 6 ohm resistance is 1 by 6 ampere. Now what is the value of I? I is simply I2 plus I3. So just write I equal to I2 plus I3, right? This will give you 1 by 3 plus 1 by 6. So this will give you 1 by 3 plus 1 by 6, which will be coming as 3 by 6, which is equal to nothing but 0.5 ampere. So the current through the main branch is 0.5 ampere. Here you can see 0.5 ampere. So I equal to here 0.5 ampere is the value of this I, which is flowing through this main circuit, right? Now we have calculated I, we have calculated I2, we have calculated I3, right? Now we have solved the first part of the question, that is that we need to find the current in the each of the resistance. So the current through the main branch is 0.5 ampere, and current through this is I2 for this 3 ohm resistance, that is 1 by 3 ampere, and the current through this 6 ohm is nothing but 1 by 6 ampere, that is I3. So this part of the question is solved, right? Now let us come to the second part. Calculate the current in each resistor. After that, the potential difference across each cell. So students, for calculating the potential difference, you need to just take this value over here. You can see here. You can see this value. That means if the resistance of 0.5 ohm, that is the internal resistance of this 4 volt, right, is there, and then we can see the I is flowing from this direction to this direction, which value is calculated at 0.5 ampere, right? So here you can see plus 4 potential difference is nothing but, if you are going from this right to left, 4 volt of the battery, right, plus 0.5 ampere into 0.5, that is current into this resistance, internal resistance, right, current into this internal resistance. So this will be giving you 4 plus 0.25, which is coming as 4.25. So 4.25 volt is the value of potential difference across this 4 volt EMF source. Now if you consider the second EMF source, so this is for 4 volt, PD for 4 volt is 4.25, right? Now again you can see the another source of current is the EMF source of 8 volt, right, and it was having an internal resistance of nothing but 1 ohm. So what is the potential difference? So potential difference this across this 8 volt of source is nothing but simply if current I is flowing through it, whose value we have calculated as 0.5 ampere, right? So I is calculated at 0.5 ampere. So from this point to this point, what are the total value of the voltage that we need to find? That is the potential difference, and this 1 ohm is the internal resistance of this cell, right? So we can write here, since minus terminal is coming first, so and current is flowing from right to left like this. So here 1 ohm into 0.5 ampere, that is due to the internal resistance, then minus 8 volt, that is the EMF source. So this will be giving you 0.5 minus 8, which is coming as 7.5 volt. So 7.5 volt is the potential difference across this 8 volt of EMF source. So in this way 7.5 volt is the potential difference for this 8 volt, and for the 4 volt source the potential difference was 4.25 volt, right? In this way we have solved the second part of the question. So here you can see for this 8 volt the potential difference was nothing but 7.5 volt, right? And for this 4 volt of resistance, here the potential difference is nothing but this 4.25 volt, right? So this is equal to 4.25 volt, right? So in this way students we have solved this question, right? For any query you can just put up into the comment box. I am always there to help you, and just keep on learning. Happy learning. Take care. Bye bye. See you. Bye students. Keep on learning. Keep your preparation on the best. And yes, this was a question from IIT. This was a JEE question which came earlier into the previous years, and I'm just today I just posted 4 questions from the JEE. Okay, definitely I think this will help you in building your concepts, and for any query just put up it to the comment box. Thank you so much. Bye bye. Take care.